All right. Are we good? Gregor, take it away.
Thank you, Owen. So, hi everyone. My name is Gregor Wobbe. I am the head of data architecture for UBS. For those of you who are not familiar with UBS, we are a global financial firm with Swiss roots. We're headquartered in the beautiful Switzerland, in Zurich. We are primarily focused on the wealth management and investment banking space. And worldwide, we have about 72,000 employees. Today, I would like to talk about our knowledge graph initiative, And whether you work for a large organization, perhaps even already in a graph-related project, or if you work for a small startup, I hope that you get some insights because I want to take you on a journey. And that journey will describe how we went from a very small POC with little to no funding to become an integral part of my firm's next generation data platform. So it all started about 3 years ago, and that actually predates me. I got hired to help solving the issue, and around 3 years ago, my boss asked a seemingly simple question. And that question was, how many applications do we have in the CRM space? Applications who manage our relationship with our clients and customers. Simple question, and little did he know, because the answer that came back was, well, it depends. And he said, what do you mean, it depends? How many applications? What's so difficult? The answer was not so simple, because they said, well, what do you want to count? We have systems, or do you want to count software components? We have applications in this little business unit. And he said, stop it. Create a working group, everyone, get me the numbers. And this is what you see up here, all those little people. They went to the central data store. It's not so central because we have quite a few of those. And they went to the source systems. ETL jobs didn't work. Tried to cobble it together. A week of frantic work resulted in a number. After many meetings, how should we interpret the numbers? And they got back to him with a number. The follow-up question was, well, how much money did we spend on it? And the answer that came back was, well, that's actually in another data warehouse. And off they went again. So it goes without saying he wasn't happy about it. And that led to defining what actually would look good. What's our nirvana state? Where do we want to be? And this is what you see here. So at the bottom, you see the operational systems. We don't want to get to it just to get to a number, because those are trading systems, operational systems that you don't want to touch. So we said, well, we want to have an analytical layer on the top, and we want to have a well-described data layer. That's the one on top. And when I say well-described, what I mean is a motivated person should get it within a day, 2 at the max. They should understand it without diving into SQL, understanding any technical jargon. That's what we mean with a well-described data layer. We want it to have that data layer be accessible for a report, and that report should be unambiguous, meaning there should be no more than one interpretation of the data. That was our goal. And then the third one, and you see that little UFO on the top, is to enable our data scientists to work with the data. Because at the moment, they spend all their waking hours trying to find the data, to massage it into the right form, and then they can generate insights. So that's what we call the nirvana state. This is where we want it to go. Our reality looked more like this. So at UBS, we created in the last decades a hodgepodge of around 5,000 applications. Each of those applications is depicted here as one of those walled gardens. So we put the data actually in the back of the house. Data is a second-class citizen. And what you see here could be data scientists, could be anyone. If you want to get to data, you have to show up at the gatekeeper. And this is not casual window shopping. You have to know exactly what you want. And then the application owner, they have no incentive to give you the data. You have to show up at the window and say, I need X, Y, Z. You need to know exactly where it is. And even then they said, oh, that's extra work. We don't have the budget. We don't have the time. What's the risk? Oh, it's cross-border. Forget about it. That's our reality. So that's reality number one. We had this walled garden, and we have 5,000 of those. Now, to address the problem, we took a little subset. That's a problem from my CTO. Out of those 5,000 applications, there are 80 that deal with technical metadata. Systems, software, people, roughly 80. That was our use case. And the second reality that hits us was this part. So even if you find the right data, you convince the application owners to expose it to you, then you have to integrate it. And we did some analysis, conservative estimate. Every time we stand up a new application, we spend roughly 60% of our cost on enterprise integration. And we are super inventive doing this in all kinds of forms and fashion. The latest fad is whatever technology is offered to us, we jump on it. Whatever helps us integrating better, cheaper, faster, you name it, we have it. It comes as a steep cost though, because there's one thing for certain, or for sure, more integration, more code means we have a higher maintenance burden. So each of those 5,000 applications is a big capital project. It costs a lot of money because we create technical debt as we go. Every time we integrate, technical debt, boom. And that costs us a lot of money. So we got together and said, maybe for our next generation data platform, let's do things a little different. Let's try to reframe the problem. And let's borrow two powerful ideas. One, and I know I'm preaching to the choir here, is the idea of a graph. And I get to this in a second, why. And the other idea is to move away from the idea, let's build one thing to rule them all. Let's move away from that paradigm and embrace a decentralized approach. So those are the two ideas that we saw. Let's apply those ideas in our next step, in our next data platform. So why graph? I get asked that question a lot of times. And the reason why we choose graph, because it's really well suited to describe any data form, be it a table, like expressing that Chuck Norris is married to Gina Norris. That is something that you can easily draw on a paper and with a graph. And any other data form that you can think of. This surprisingly caused the most discussions in my firm. And that really surprised me. And it's on a spectrum from, oh yeah, data model. We tried that a lot of times. The enterprise data model, tried it often, it never works. That's on one side of the spectrum. On the other side of the spectrum are the data modelers who say, well, it's not UML. You cannot do that. Or why is it not in Urban or any other tool? So in between, that's probably where I spend most of my calories convincing the organization that actually a good idea to express data in a common form. So what we want, because we want to be data-centric, we want to have a single data model. It should be simple, and it should be extensible. And we found RDF to be well suited for this. But again, there is no shortage of discussion and religious fights if there's not something better out there. And we are open. But so far, it works quite well on the web and the internet with schema.org. It works okay for us as well. So before I get to the second idea, the federated, I have to explain a little piece of software that we created. It's called a data service, or we call it a data service. And think of it almost like a cell in the human body. This is a generic cell that can play multiple roles. It can be specialized. So we created this data service, and basically what it does, it gobbles up the data from our source systems and turns it into connected data. And those data services is something that we built and that we now give to every application. And this is how it looks in a decentralized mode. So every application gets its own data service. And that data service can play two roles. It can hoover up the data and turns it into connected data, or it can expose that connected data via UI. And what it allows us is to scale. We can now jump from one domain to another, and we can seamlessly connect across the enterprise. And that's something that we hadn't had before. And that's also something that plays extremely well together with other technologies, be it streaming technology or data lakes. Again, we have multiple data lakes. It's not the definition, it should be the one to rule them all, but our reality is we have multiples, and we need to cross them. We need to jump from one to the next. To answer, for example, a question with how many CRM systems do we have? How much does it cost? That is a double hop. So those two ideas is what we implemented. And to bring this all together in the big picture, it's a bit more, it's a busy diagram and more technical. At the bottom, you have what we call the publishers. Those are the ones that say, I have data as a product. I want to expose it. And they get their data service, and they expose, that was a picture before. Data gets hoovered up and exposed into our upper ontology. That is then in the connected form. That's how they expose it. On the top, you see the same data services. They're all on Kubernetes, so we can, as long as we can swipe the credit card and buy more cloud storage on Kubernetes, we can scale. And we give every consumer another data service. And one example, and that's was our first, Jacobus would call it lighthouse project. Learned something new today. That was our first use case, our first prototype that we built, something that we call bank on a page. And what it does is it gives you a bird's eye view of the entire estate that we have. And that bird's eye view is highly interactive. So you open it up and it shows you 5,000 applications. And then you can swap in lenses saying, show me all the applications in a specific business capability. For example, customer relationship management or trading and finance, whatever the capability may be. Now swap in another lens. Show me out of those applications, show me the ones that have end-of-life software, for example. Or swap in a lens to show me what is my vulnerability. And that proved extremely powerful because now you can answer a lot of questions with a single user interface. And our senior management loves it because it answers a question. For example, the question, what is our risk for the log4j vulnerability? You can just swap in a lens of vulnerability. It comes from a complete different domain. That's our central vulnerability management systems. And we don't have one, we have 18 vulnerability management systems. It swaps that whole lens in, and our senior management can see within 2 minutes, oh, here's our exposure to log4j. Here's where we expose ourselves to vulnerabilities to the internet. Here's something where you can do, or we need to invest to fix it. So that's the high-level picture. And you also see there's a big application 1, big application 2. Along the way, we learned something. Not everything needs to be in a graph, and not everything should be in a graph. And what I mean with this is that there's a lot of data sets that we have that are tabular in nature and very deep, very large. And they have a high volume. That's especially our trading data. There's not really a point of putting it into a graph. This is more where you need to aggregate. And what we do there is we leverage Kafka. And there's also the big app 1, big app 2. Those are producers that are just funneling trading data into our Kafka streaming platform. Billions of records, doesn't really make sense to put it in a graph. What we do though, is we annotate the Kafka topics with JSON schema. And that JSON schema links back to our internal version of schema.org. We have a schema.org for UBS. The reason why we do this is to have all the data explainable. So if someone goes to Kafka topic and reads the data, they want to know what does that mean. And they go to our internal schema.org, look up what it means, and that's our lightweight footprint to at least explain the data. That brings me to lessons learned along the way. The first one is what I call the single domain wins. And if you're on a similar journey, I highly recommend, and this is, I know it sounds like a platitude, probably applies to every software project, is do one thing and do it really well. And the one thing that you do well, expose it, deliver it in small increments. And the way I did it was I demoed every 2 weeks to various stakeholders, to management, to whoever was willing to listen. And in those demos, I demoed only 2 things, but I did it every 2 weeks. Small increment wins, and that's what I call the single domain wins. And the audience was already aware that it's 2 weeks in, let's see what Gregor has new to show us. The second lesson learned is to invest in a visual anchor. And there was this bank on a page, there was our visual anchor. And we invested, that was the first time that I hired a UX developer just for a specific use case. And there was this initial job description was, I need you to build this, make this amazing. And I told him, I don't know what amazing looks like, but you figure it out. And he went, and for 6 months, we iterated over it and over it. So we invested heavily in the user experience because our stakeholders are used to apps on the iPhone. You cannot really wow them with a Tableau dashboard. Nothing wrong with Tableau. It's great for reports. But for a visual anchor, it doesn't fly. So that's my recommendation, to invest heavily in the user experience. And the third one, also no surprise, is to limit the amount of technical talk, technical jargon. And I see this over and over and over again. And that's something that we love our technology so much. Every time we come up with a new feature, everyone is high-fiving, and we talk about it in very technical terms. Put yourself in the shoes of your stakeholders, the ones with a budget. Same applies to all the machine learning folks in here. I always cringe when I see Jupyter Notebook and we run through 100 lines of Python code. It's crazy. It's not selling. There are only a few people who can pull this off in Jupyter. Jupyter is awesome, just not for presentation. So if you do it, no technical jargon, and please do not run through 100 Python code, lines of Python code. If you do it with other developers, awesome. By all means, all the power to you. Go for it. But I would highly recommend to limit the amount of technical jargon and really focus on the audience. So that brings me to the end of my journey. No Swiss slide deck without beautiful mountains. We reached the peak. Would like to hand it over to you. Thank you very much for listening. Any questions? Yes, please.
Hold on, give me a second. We got folks online.
That's your workout.
Hi, thanks. Can you show examples of the UX you developed, or can you talk to it in any length?
Unfortunately, I'm not allowed. We deem this as a competitive advantage. You could also tell, like, my slide decks are all hand-drawn. Those slides made it through the corporate communications team. I'm not at liberty to show any examples.
Yeah. Okay. So 1, 2, 3. What's interesting, and 4. What's interesting is how UX is a competitive advantage. I like that.
Hi, thanks for the presentation. Are you able to go in a little deeper into how you handle the Hoover and when different applications might deal with the same concept? For example, your different applications are going to have their own versions of currency. Is there any reconciliation you do when you Hoover them up?
Oh, I love that question. Thank you. So we Hoover them up, and I want to make sure I understand the question. If you have multiple applications feeding the same concept, yes, we have that a lot, and we have them battle it out. We expose, we say, here's our top-level ontology. Here's your specialized ontology. Now you tell us what the structure should be. And then we let them battle it out. And we're not there yet. The idea is, right now, our biggest problem is to incentivize the applications to share their data. And one of our ideas is to tie data sharing to financial reward. We're not there yet, but that's where we are heading. So the goal is really to make data as a product and say, I know you were 3 separate applications, get together, form a new team, call them now pods, form a new pod, and you share your data. Become a data union, and then share the rewards. Get a little budget to build the data union. Let them battle it out.
Is that in the absence of governance, or is that complementary?
Complementary.
Yeah. Hi, great. Thank you. It was a terrific presentation. Did you do the drawings?
I did not. Thank you.
You would have had extra kudos. Yeah, I wanted to ask you about all of these thousands of apps, legacy apps, and how they consume the data. You talked about data services. Is the argument there that the legacy apps should now draw strictly from online data services, or do they ditch the legacy database? How do you handle all of the legacy applications?
Very good question. Thank you. We're not ditching any applications. So we're seeing ourselves as a glue. And we just say, if you have data, if you deal with data, and most of those applications are operational systems, we say, do your work. We're not here to get rid of you, quite the opposite. We're just exposing your data into a wider ecosystem. We're the glue in between all of you legacy applications. They're actually not all legacy. We're just saying we're the glue between your applications and helping you exposing your data so that people can generate insights and generate value from it.
Hi, thank you. My question is somewhat related to that. As we try to implement knowledge graphs into an organization, let's say an organization's been around for quite a long time.
Mhm.
They have, again, legacy databases, SQL servers of all types. How did you get the buy-in as far as making the additional cost of adding graph databases or some type of other type of connection there, as well as the development? Because the skill sets changed somewhat.
Mhm.
You need individuals now that have a different type of skill set that you would normally have with a regular SQL or Oracle database. How did you get that buy-in? Was there some rationalization done on that? And how do you determine your return on investment on something like that?
Excellent question. Oh, thank you. Great questions today. Thanks. It's one of the hardest problems to get the buy-in. We backsteal, trying to convince. We piggyback on other data initiatives, namely our enterprise Kafka bus, for lack of a better word, that we siphon data off and then convince the producers that this is actually good stuff. And you have data is valuable, and here's how others are using it, to convince them to install one of the data services themselves. But it's one of our biggest challenges to change the mindset from an application-centric mindset to sharing is caring and make data a first-class citizen.
Hi.
Hi.
So I am a community person, former head of community here at KGC, and I think that there's a lot of technical work that goes into engaging the stakeholders, but we often don't hear about that, right? And you have the success. So I'm curious about sort of this investment that you got from the initial executive who wanted the answer to the question, the people that came to your demo. How did you, this is a rather large time investment. How did you sell that at the very beginning to get this sort of, a really high level of interest?
Very good question. Thank you. What I alluded in my lessons learned, those small wins, is work on one use case after another and provide incremental value back to the larger organization. And then word gets out. It's like, oh, those guys, they do actually cool stuff. Check it out. And little by little, it takes a lot of time and energy to get over the hump. Now it's almost running by itself. So people approach, we have a hard time saying no, or actually we have a hard time committing nowadays. We have to say more often than not, we have to say no, sorry, we cannot help you.
All right. With that, we have to wrap up. We're going to have a panel in the afternoon, and Gregor is going to be on the panel, so we'll keep talking about more of the architecture. So with that, thank you very much.
Thank
Gregor.
you.
Applause.